Hey, boys and girls, it's lesson 42, repeating decimals. I know you've seen it before, so you're gonna rock this stuff. But first, get your brain warmed up and do that warm up. Have a great time.
All right, we have one vocabulary word for this lesson. And let's take, I know you've seen these before. They're called repeating decimals, where we get into situations where our decimal goes and goes and goes and goes and never ends. And we would call this an irrational number, and we'll talk about that more hopefully this year, and especially in algebra. So as these dots may mean, I put a lot of dots there. I don't know why. There should only just be 3. That's what the book will use. All those dots mean that whatever you just saw will continue. Okay? And we call them repeating. And the digits that repeat, the digits of a decimal number that repeat, are called the repetend. So that is your vocab word for the day, repetend. Now, if you put it in Microsoft Word, they're going to underline it and say it's not a real word and call it wrong. So that's interesting to me. They just don't have the math vocabulary in there. So repetend, R-E-P-E-T-E-N-D. And we get that from the word repeat, right? So if we were to write this without the dots and over, we would put a bar over the repeating digits, just the repeating ones. So in this case, the 6s are the ones that repeat. So we would write 7.16 and we put the bar over the 6. That means the 6 will go on and on and on. Now look at this. A pattern repeats not just one digit. What repeats is 181818. So we would write 18, stop right there, and put a bar over the 1 and the 8 together. So let's go ahead and do an example. Rewrite each of these repeating decimals with a bar over the repetend. So go ahead and do that right now, and maybe I will do it quietly, and then I want you to look up and make sure you did it correctly. Second one is probably the tricky one, so you really got to look for where does the pattern repeat itself. Oops, don't push too hard. And the last one, oh, and to tell you too, the bar always happens in the decimal side of things. We don't do it, it has to be the right of, the repetend is always to the right of the decimal point. So we don't write a bar over a whole number or something before the decimal point. So we would write 454 dot, or 0.54 and put the bar over the 54. All right. Let's look at it from a different point of view. Round each number to 5 decimal places. So now what we're basically is we're just reversing the process that we just did. So now what we do is take it out 5 decimal places. So if I do this, I write 5.31 and then 6. So that's 3 decimal places, 4 decimal places, and we're going to round it. So the 5th decimal place here, if we did that, it would go out that many places. Now we don't just cut it off. We can't do that. We have to actually look at this number after it and go, oh, that's a 6. This 6 is big enough to round that up to a 7. So our answer there should actually be 5.31667. All right. And the next one, 25.405. So that's out 3 places, 4 places, 5 places, but we need to look at that 6th place to see if it's got the power to move that 0 up to a 1, and it does. So if we go out 5 decimal places, it should be 25.40541. when we round. Okay, so even though it says round 5 decimal places, we have to take it out 6 decimal places so that we round it properly. Example 3, last example. This is going to be a short lesson today. Divide 1.5 by 11 and write the quotient with a bar over the repetend or as rounded to the nearest hundredth. So let's first do the division. 1.5 divided by 11. Okay, so I already am guessing, since we're going to be in decimal world, sometimes I just like to write some zeros so I have some placeholders there. And we're dividing by 11, which is nice because we know our multiples of 11, right? 11, 22, 33, 44. So that was kind of a nice gift they gave to us. So we're just, and remember, bring the decimal up. So what we get here, and let's see, they want us to, well, I don't see a repetend yet. I don't see a repeater, so I'm just going to keep going. Oh, there it is. There's that 3 again. And the 70, and as you can tell, we're going to keep going. So we get to just stop like that, and we are going to write the answer with a bar over the repetend. So it looks like 3, 6 is the part that repeats. So there is our final answer there with a bar over the repetend. And now round it to the nearest hundredth. So let's look. Tenths, hundredths, right here. So we're going to round to this spot, but we've got to look at the 6 and go, okay, is the 6 big enough to round it up? Yes. So the answer is 0.14 for that part. Now, before we go into practice, I'm going to show you something with a calculator. What does a calculator do when we've got repeating decimals? When a division problem is entered, so let's take the one we just did, 1.5 divided by 11. Okay, so here is what we had just gotten, which is great, right? But let's do 1 divided by 7. 1 divided by 7. And let's look really close here. 142, 857, 142, probably repeating, or it looks repeating. When a division problem is entered into a calculator and the display is filled with a decimal number, it's likely that the quotient is a repeating decimal. That happens a lot when it's filled. So usually when your display has this many digits, it's likely we've got a repeating decimal. Not always, though. Since a calculator either cuts off or rounds the number displayed, and that's called truncates. Sometimes it just cuts off the next digit instead, or it rounds it. The repetend may not be obvious. If we were looking at something like this, it might not be obvious as far as, like, you see 0.142, this stuff 142. We might not be positive that we saw. We might wonder whether the final digit there was a 1. Now in the book, theirs stops right here. I have a nice calculator, I guess. I didn't realize that, but theirs stops right here. And so they couldn't tell it was a repeater. But let's say you didn't know, how could you fix that? Well, what we just did was 1 divided by 7. Remember I did 1 divided by 7? And I got that. What if we multiplied 1 times 10? What if we did 10 divided by 7? Now what's happened was the decimal moved over 1. Remember it was 0.142. What this does is move the decimal over 1 and gives us another spot to look at. In fact, wouldn't it be interesting to see if 100 divided by 7 works? Well, no, it still will go out to the 8. But they're just showing you can use your calculator and try different methods to see if in fact it really is a repeating decimal or not. This does show at least 4 digits repeating, so you can be pretty confident that this is a repeating decimal. All right, let's look at the practice. Go ahead and do this and then check your answers in the solution manual, and then only come back to this if you don't happen to get these correct. Okay, and you may begin. So I'm going to rewrite it as 2.72 with the bar over there. And the next one, the bar goes over the 6. And in this one now, I have to fix this. Anyway, we're going to round each number to the nearest thousandth. So what that would be tens, hundredths, thousandths is the spot. But I know this is going to be a 6, so this is going to have to round up to a 0.667. This one is going to be 5.381. And we know that next one is an 8. So that 8 will round that up to a 2. So that is the answer for that one. All right, the last one is a division problem, and then we're going to show the answer 2 ways. So 1.7 divided by 12. That was another nice bonus because we know our 12s, right? Hopefully we do at this point. So 12 goes into 17 one time. Goes in there 4. I'm not noticing anything yet. Ah, there we go. There we go. All right, so it looks like this one's just going to keep going, right? So let's write it with a bar over the repetend. 1416 with the bar. Rounded 4 decimal places. So we round around to that spot. Well, the 6 is going to round this one up to a 7, so there we go. Is our answer for that one. And oh, that was it. So have fun with that, and we will go on to the next lesson. And I believe that one will be pretty short and sweet as well.